Students, we want to take a little time and talk about equivalent statements and variations of conditional statements. Let's see what we're talking about. We want to use a truth table to show when two statements are equivalent. We also want to sort of prove that the contrapositive of a conditional statement is equivalent to the given statement. And then we want to talk about the converse and the inverse. So let's take a look at this. Now, in your book, there's a graphic about different Oscar nominations and different people. And according to the graph, Paul Newman and Spencer Tracy have 9 Oscar nominations. Now, I want you to consider this given statement. If the actor is Paul Newman, he received 9 Oscar nominations. Well, that's true. Paul Newman right here, 9. Now, what would be the converse? If he received 9 Oscar nominations, the actor is Paul Newman. Is that necessarily true? There's 2 that received 9. If the actor is not Paul Newman, he did not receive 9 Oscar nominations. Well, this actor is not Paul Newman, but he received 9 Oscar nominations. Or how about this last statement? If he did not receive 9 Oscar nominations, the actor is not Paul Newman. Well, no, that does make sense. If he did not receive 9, it's either this gentleman here or Jack Nicholson, and they did not receive 9. So the given statement really only lines up with the last statement. And that's a little introductory idea. All right, let's look at a question about Miguel. Okay, so we got this Miguel individual, and what do we know? We're going to call Miguel is blushing. Let's put that as P. I hate to change the size right there, but anyway, that's P. And Miguel is blushing, and here is Q. Miguel is sunburned. Miguel is blushing, or Miguel is sunburned. Blushing or sunburned. All right, what is A? If Miguel is blushing, that's P. If P, then not Q. He's not sunburned. Miguel is sunburned or blushing. Okay, Miguel is sunburned or blushing. Now I did that wrong. Got to read it carefully. Miguel is sunburned, that's Q or P. And then the C part, if Miguel is not blushing, that would be if not P, then he is sunburned, Q. And lastly, if Miguel is not sunburned, then he is blushing. Okay, now notice all of these compound statements with connectives they're all different. Okay, now the question is, select a statement that is not equivalent. What is not equivalent to the given statement? That is a good question. So we're going to look at this. 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 Now, if you notice in this chart, here's A, and then here's B right here. Here's C, and here's D. All right, and then here's the given statement. Notice the given statement: true, 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 false. Okay, and notice all these other statements: true, 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 false, true, 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 false, true, 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 false. And this statement is not equivalent. So it would be A. A is not equivalent. Now, we're going to see what the ramifications are of that before too long, but just keep that thought in mind. Now, when we talk about equivalent statements, the bottom line is we are looking for compound statements that use the same P's and Q's, and they have the same corresponding truth values for all true-false combinations of the simple statements. That's what we're talking about when we talk about equivalent statements. Now, here's one thing we know. If a compound statement is true, then its equivalent statement must also be true. If the compound statement is false, the equivalent must be false as well. Sometimes people say, well, let me say that in other words, right? An equivalent statement. Now notice here I have two statements. I have P or not Q, and then I have if not P, then not Q. Are they equivalent? Well, we notice over here we've got our chart the way we've been doing it. And here's this statement right here. We got that. And then here's this second statement. And notice that true, true, false, true, 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 false, true, they are the same, which, given the rules of logic, we could say something in English the same way. We could say it in two different ways and mean the same thing. That is very interesting. Okay, and that gives us some insight into how language and logic work together. All right, let's review for a second. The given statement and the contrapositive are always equivalent. The given statement, conditional statement, and the contrapositive are always equivalent. All right, so let's look at an example. Los Angeles is in the news a lot. Okay, of course, that's in California, right? All right, so if you live in Los Angeles, then you live in California. That makes sense. Here's P and here's Q. Now, could I say that statement using the contrapositive? What would that be? If you do not live in California, then you do not live in Los Angeles. That makes sense. If I do not live in Georgia, I do not live in Atlanta. That does make sense. Okay, this is sort of a rehash of what you learned in high school. You have your given conditional. The converse is just switching the Q and the P. The inverse is negating them but keeping the order. And the contrapositive is a combination of the converse and inverse. You are switching the P's and Q's and negating both of them. So keep that in mind. All right, so let's just use an example. All right, that makes sense. Now, years ago, lead pencils probably did have lead. But as you know, lead caused a lot of problems with people and with children. And you could get lead poisoning. And how many of us have put a pencil in our mouth? So even though we call it a lead pencil, that is some carbon graphite material in the middle of the pencil. Even those that are, the .07 clicker type pencils. Anyway, here's our given statement. If it is a lead pencil, then it does not contain lead. If we have an item in our hands, we're calling it a lead pencil, then it does not contain lead. That is true. Okay? Weird, but true. Now, let's consider all the possibilities. Here's our given statement, so we got that. I told you that was true. If it does not contain lead, then it's a lead pencil. Well, if it does not contain, my coffee cup does not contain lead, it's not a lead pencil. If it is not a lead pencil, then it contains lead. My fishing tackle box has something that's not a lead pencil, and it does have lead. So if it is not a lead pencil, then it contains lead. Well, that item did, but my fishing box also contains lures, and they are not a lead pencil, and they don't contain lead. Look at the last statement. If it contains lead, then it is not a lead pencil. If it contains lead, well, my fishing lure, my fishing weight that is, made up of lead, right, contains lead. then it is not a lead pencil. Well, that's true. If it contains lead, then it's not a lead pencil. That makes sense. Now remember, a lead pencil, we're understanding that as something that contains graphite. Okay? Keep that in mind. That's an example. Hope it didn't confuse you. All right, so that's what we're learning on lesson 3.5. And again, on the assignments, I'll be happy to do a couple when we come to class. You're going to take whatever the two statements are, and you're going to build your table, and you're going to compare the two statements. And if they're not matching item for item, then they're not equivalent. Okay? So, with a little more thinking, you could see how we could break down people's words and sentences and see if they are equivalent or not equivalent. That's interesting. That's all I want to say about this video 3.5.